And welcome again. We have yet another problem in which capacitance of a system needs to be found. And this time we are going to find the capacitance of a pair of long wires. And you can see the problem as it reads: two long wires of radius A are in the air parallel to each other. The distance between their axes B is much less than A. Find the relative change delta C by C naught in the capacity of the wire system per unit length. If the distance between the axis of the wires is reduced by 2 times, that is halved, and we can solve it as well. So we need to find out capacitance per unit length. That means we can easily provide not the charges but linear charge densities to both of these wires, and let one wire be charged with linear charge density lambda and the other with minus lambda. And as we did in the last problem, we can take an x-axis along the line joining these wires, axis of the wires, and put the origin here, and we will locate a point at a distance x from center of one of the wires, call it a point P, and let us find the electric field here at this point. And you can see here that this electric field will be simply for the left wire you can write it is lambda upon 2 pi epsilon naught x, and for the right wire it will be, both will be in same direction. So for the right wire it will get added and it can be written as lambda upon 2 pi epsilon naught b minus x, not x but b minus x, this. And this time we can find the potential difference between the surfaces of the wires, and we can write potential difference as delta phi or u or v. I'm writing this time as delta phi, and this will be integrated from the relation E dx minus A dx to be precise, but I'm going to find out not the potential difference but the voltage, that is higher potential minus lower potential. So I will avoid using this negative sign, and I can write this simply as this. And so putting the values of obtained electric field, we can write it as lambda upon 2 pi epsilon naught 1 by x plus 1 by p minus x dx, and just by putting the limits from a to b minus a, and after integrating we will get the result lambda by pi epsilon naught, sorry, not 2 pi epsilon naught, but it can be written as lambda by pi epsilon naught. I just got using, and I just got this result by calculating this integration as lambda by pi epsilon naught ln b minus a by a. And now this capacitance C naught we got, that is capacitance per unit length of wires of the system, and this C naught can be simply written as lambda by u, that is capacitance per unit length, and this is basically pi epsilon naught by ln b minus a by a, which can be further written as pi epsilon naught ln b by a. And Now we need to find other things as given in the problem. If we reduce the distance between the wires by 2 times, that is, distance is being halved between the wires, the capacitance, now call this C1, it will become pi epsilon naught divided by ln b by 2 divided by a, because nothing has changed except the b, and b has become b by 2. And now capacitance will increase so that delta C can be written as C1 minus C0, and you can calculate, it will come out simply like pi epsilon naught ln 2 by ln b by a ln b by 2a. And so the relative increase in capacitance that was being asked in the problem, that was something like delta C by C0, it will come out simply as ln 2 divided by ln b by 2a, and that's the result we were needing. Thank you very much for watching.